Hi friends, welcome to my new channel Roy Formulation. Here we will discuss on the standard quadratic congruence of composite modulus. Let us try to understand what is a standard quadratic congruence. Now, if x is any integer, either it is positive or negative, pointer, its square. If x square is always positive number, when this square is divided by any positive number, say m, we get the remainder r. Actually we get quotient also, but our concern is with remainder, not quotient. That means whenever x square in unknown number, its square is divided by m, we get remainder r. Then this is written in this for symbol as x square congruent to r mod m. It is called a standard quadratic congruence. Congruence of modulus m. If this m it is a prime number, then it is called quadratic congruence of prime modulus. If m is any composite number, then congruence is called x square congruent to r mod m is composite number. It is called a standard quadratic congruence of composite modulus. So we have two types of quadratic congruences: congruence of prime modulus and congruence of composite modulus. Now, if r is a quadratic residue of m. Quadratic residue means the remainder. When divided by a number, we get some remainder. That remainder is also called residue. Here r is called a remainder, means we are calling residue. Means quadratic residue means, quadratic means square. When a square number is divided by m, we will get the number that is called quadratic residue. If r is a quadratic residue, means r is divided, when r square is divided by m, we get a number that is the quadratic residue. Then congruence is solvable. If r is a quadratic residue, then it is solvable. Otherwise, it is not solvable. Means r is not a quadratic residue, means non-residue, non-quadratic residue, then congruence is not solvable. You know that solvability condition, when the legendary symbol of this r with m, that is, this is the symbol r for m. This is called legendary symbol. When this symbol has value 1, it is called solvable. When it has value minus 1, it is not solvable. Means when r is quadratic non-residue, congruence is not solvable. When r is quadratic residue, then congruence is solvable. So this is called condition of solvability. Congruence will be solvable when r is a quadratic residue. When any remainder, its square is again divided by a, will get the remainder, that is called quadratic residue. Let us try to understand for example. Here our congruence is x square Here our congruence is x square congruent to r mod m. Now, if we put m is equal to p, p means a prime number, then our congruence becomes x square congruent to r mod p. So this is a standard quadratic congruence of prime modulus where p is a prime number. X square congruent to r mod p is a composite a prime modulus, congruence of prime modulus. If m is composite, then x square congruent to r mod m is quadratic congruence of composite modulus. Now, in that case, we have considered the quadratic congruence of composite modulus. We discuss the solution of standard quadratic congruence of composite modulus. Means this number will be a composite number. Let our m is equal to pq. P is a prime and q is also a prime. M is a product of two primes. It is a composite number. So our congruence becomes, in that case, x square congruent to r mod pq. Then question arises whether this congruence is solvable or not. The condition of solvability is to test, because some quadratic congruences are solvable and some quadratic congruences are not solvable. Whether our this congruence is solvable or not, that is also to test by using Legendre symbol. When Legendre symbol of r and p2 is 1, that is solvable, otherwise it is not solvable. But in that case, we have to consider that r, for solvability, r will be always a quadratic residue. That means if r is equal to a square mod pq, then our congruence becomes x square congruent to a square mod pq. Now, x a square, it is always a square number, it is a quadratic residue. This number is a square number. When this is a square number, the congruence is always solvable. So a square is a quadratic residue, because r is square and it is divided by a pq, we obtain the number. That is, a square is a quadratic residue of pq. So congruence is always solvable. Our YouTube is full of lectures on quadratic congruences, quadratic congruence of prime modulus, also quadratic congruence of composite modulus. But they use generally Chinese remainder theorem. There is no formulation, means there is no formula for the solution of the congruence. But here I am going to present a formulation of solutions of quadratic congruences. Here our congruence is, consider the congruence x square congruent to a square mod pq, as modulus is a p into q, that is a factor, two factors p and q. So it is a standard quadratic congruence. It is a standard quadratic congruence of composite modulus PQ. Standard quadratic congruence of modulus. It is always solvable. So what are the solution? So it means values of x, means we have to find what are the values of x so that this congruence is satisfied. It has 4 solutions. If you separate the congruence, it becomes x square congruent to a square mod p, x square congruent to a square mod q. So there are two congruences. Their congruence of prime modulus always has two solutions. It is a combination of two congruences of prime modulus, and both have two solutions. So total solution will be 4. Here this congruence has 4 solutions, and we have to determine these 4 values. Two obvious solutions are x congruent to plus minus, that a square is plus minus a mod pq, and this plus minus a is written as 1 is a, and minus a means pq minus a mod pq. These are the two solutions, and among the 4, 2 are obtained. That is very obvious solutions. Other two solutions are, they are given by this formula. X is congruent to plus minus pk plus minus a mod pq. If and only if under this condition, not always, that whenever k into pk plus minus 2a equal to qt. Under this condition, whenever that k into pk plus minus 2a, but this a it's double, 2a is equal to qt, this q, then this will be the solution, plus minus pk plus minus a mod pq. This is the formulation. These are my formulation. Actually, I have obtained this formulation for this quadratic congruence of composite modulus, and modulus is a product of two primes. Modulus is a product of two primes. X square congruent to a square mod pq. Solutions are given. Two of the solutions are square root of a square means plus minus a, means a and pq minus a, and other two remaining solutions are given by this formula, that x congruent to plus minus pk plus minus a mod pq. Under this condition, k into pk plus minus 2a equal to qt. If this condition holds, only then these will be the two solutions. Otherwise, they are not solutions. Only we have to decide the value of k. If we know the value of k, here p is given, a is given, q are given, only to find k. For one value of k, this will be satisfied. For that value of k, here we will get the two solutions. Okay. So let us start with an example. Consider the congruence x square congruent to 4 mod 91. X square congruent to 4 mod 91. It can be written as that x square congruent to 4 is a perfect square, the square of 2 mod. Now 91 can be written as the product of 13 into 7. 91 means 13 into 7. It is of the type, what type? That x square congruent to a square mod pq, with what is the value of a? Compare the 2. A is equal to 2. Compare here. P equal to 13 and Q equal to 7. Now here it is a square number. X square equal to a square. Such type of congruence is always solvable, and it has 4 solutions. It has 4 solutions. 2 obvious solutions are x is congruent to plus minus a means plus minus a mod PQ is your formula. That means plus minus 2 mod 13 into 7. That means 2 minus 2 means 91 minus 2 mod 91, totally 2 into 89 mod 91. These are the two obvious solutions. 2 and 89 means x square into a square, so x is equal to plus minus a, and a square a is 2. X is equal to plus minus 2 mod PQ. P into Q means 91 here. And minus 2 means that mod minus 2. That is 91 minus 2 means 89. So 2 and 89 are the two solutions of the congruence modulo 91. We have to find 4 solutions. These are the 2 solutions. Other 2 solutions are given by this formula, that x is congruent to plus minus pk plus minus a mod pq if and only if k into pk plus 1 here is 2a is equal to qt. We have to memorize this formula. Now put the values of p, a and q. That is plus minus p means 13k plus minus a is equal to 2 mod p equal to 13, q equal to 7. If and only if k into 13k plus minus 2 into 2 is equal to 70. The known values of q, a and p are substituted in the formula. Here also p and a. And simplifying, what we get? Plus minus 13k plus minus 2 mod 91. If this gives k into 13k plus minus 4 is equal to 70. And therefrom, we have to decide the value of k. For a particular value of k, this equation will be satisfied. And for that value of k, it will give the 2 solutions. Now see here, there are 2 possibilities, plus and minus. Now test. If we put k equal to 1, what we get? 13 plus minus 4 equal to 70. Now 13 plus 4 is, for k equal to 1, 13 plus 4 becomes 17, not divisible by 7, but 13 minus 4 is equal to 7. 13 k equal to 7. K equal to, okay, k equal to 22. Huh? Here for k equal to 1, it becomes 13 plus 4, not divisible by 7. 13 minus 4, not divisible by 7. If we put k equal to 2, 13 into 26, 26 plus 4, 30, not divisible by 7. 26 minus 4 also not divisible. But if we put k equal to 3, for k equal to 3, 13 into 3, 39. 39 plus 4, not divisible by 7, but 39 minus 4. We'll get that 3 into 13 into 3 minus 4 is equal to 35. 3 into 35. And 3 into 35 is divisible by 7. So k equal to 3 works here. For k equal to 3, 13 into 3 plus minus 4 is 35, that is divisible by 7. So k equal to 3 works here. For that value of k, we obtain solution, that is plus minus 13 into 3 minus 2, because we have minus sign here, mod 91, that is plus minus 3 into 39. 3 into 3 into 39. 39 minus 2 is 37. Mod 91. Here also plus minus 37. 1 is 37. And other 91 minus 37. Mod 91. Now see the values. 1 is 37 and 91 minus 39 is. So 91 minus 37 is 54. That is 54 mod 91. Therefore, we have the solutions. The 4 solutions are x is congruent to 2 and 89. These are the first pair of solutions, and second pair of solution was 37 and 54 mod 91. So these are the 4 solutions. So let us take a problem for yourself as homework, you can say. Solve x square congruent to 9 mod 77.